This video is about rationalizing numerators of radical expressions, and so it basically works just like with the denominators, only this time we want to get the square roots out of the numerator and not the denominator. So we're still going to be using conjugates, and we're going to multiply by the conjugate of the numerator. Our first example is 2x to the square root of 2x to the 7th over 8, and we can simplify this square root in the numerator a little bit. 2 goes into 7 3 times, and so that would be x cubed square root of 2x over 8. And you can't simplify the 2 with 8 because the 2 is underneath the square root and the 8 is not. And so the square root that we want to get rid of is the one in the numerator, and so we're going to multiply by the square root of 2x on both the top and the bottom. So on the top then we have our x cubed, and then square root of 2x times the square root of 2x is just 2x. And on the bottom we have 8 times the square root of 2x. And 2 goes into itself once and into the 8 twice, or into the 8 4 times, sorry. And so you can simplify that. And so on the top we're left with x to the 4th, and on the bottom we have 4 times the square root of 2x. And again, you can't simplify that any further. This x is under the denominator, or under the square root. This one is not under a square root. The next one, again, we want to simplify this if we can. And so 16 divided by 4 is 4. And then we have x to the 5th, and that's over z. And this is all underneath our square root. And the square root of 4x to the 5th over the square root of z. And we can take the square root of 4, it's 2. And our root here is 2, and 2 goes into 5 twice, so we can pull out an x squared. And what's left underneath this square root then is x. And on the bottom we have the square root of z. So what we're trying to do is get rid of the radical in our numerator, so we want to multiply both the numerator and denominator by the square root of x. So we have 2x squared, and then the square root of x times the square root of x is x. And in the denominator, square root of z times the square root of x is the square root of xz. So in our numerator we have 2x cubed, and in the denominator we have the square root of xz. In our next example, we have the square root of 13 plus 1 divided by 2. So again, we're trying to eliminate this radical or square root in our numerator. So we need to multiply by the conjugate of the square root of 13 plus 1, which is the square root of 13 minus 1. So we have square root of 13 plus 1 times square root of 13 minus 1 on the top. And on the bottom, we have 2 times the quantity square root of 13 minus 1. Doing FOIL on the top, we get the square root of 13 times the square root of 13, which is 13. And then square root of 13 times negative 1 is negative square root of 13. And 1 times the square root of 13 is square root of 13. And then 1 times negative 1 is negative 1. So on the top, these two square roots cancel out to give us 0, and 13 minus 1 is 12. And then we have 2 times the quantity square root of 13 minus 1. And this is why I like to leave this factored, is because now I can cancel the 2 with a 12. 2 goes into itself once, and into 12 6 times, and so we get 6 over the square root of 13 minus 1. Our next example, 3 minus the square root of 11 over negative 4. So we want to multiply by the conjugate of 3 minus the square root of 11, which will be 3 plus the square root of 11. So on the top, we have 3 minus the square root of 11 times 3 plus the square root of 11. And on the bottom, we have negative 4 times 3 plus the square root of 11. Do FOIL on the top. 3 times 3 is 9. 3 times the square root of 11 is 3 square root of 11. And negative square root of 11 times 3 is negative 3 square root of 11. And negative square root of 11 times positive square root of 11 is negative 11. And so on the top, we have 9 and negative 11 is negative 2. These two middle terms cancel out to give you 0. So we have negative 2 over negative 4 times the quantity 3 plus the square root of 11. And so we can divide both the top and the bottom actually by negative 2 here. That would leave a 1 on the top and a positive 2 on the bottom. So we would have 1 over 2 times the quantity 3 plus the square root of 11. Or if you distribute the 2 on the bottom, we would have 1 over 6 plus 2 square root of 11. Either one of these answers is correct. Our next one, square root of x minus 1 over square root of x plus 1. So we need to multiply by the conjugate of our numerator, so that'll be the square root of x plus 1. So on the top, we have square root of x minus 1 times square root of x plus 1. And on the bottom, we have square root of x plus 1 times square root of x plus 1. Do FOIL on both the top and the bottom. Square root of x times the square root of x is x. Square root of x times 1 is square root of x. Negative 1 times square root of x is negative square root of x. And negative 1 times 1 is negative 1. On the bottom, square root of x times the square root of x is x. Square root of x times 1 is square root of x. 1 times the square root of x is another square root of x. And 1 times 1 is 1. These two middle terms on the top cancel to give us 0, so on the top I'm left with x minus 1. And on the bottom I have x. I have square root of x plus the square root of x, so that's plus 2 square root of x. And then we have plus 1. And you cannot cancel anything, you have to leave it just like that. And our last example, square root of x plus 2 square root of y over 3 square root of x. So we're multiplying by the conjugate of our numerator, square root of x minus 2 square root of y. And we're going to do FOIL. Square root of x plus 2 square root of y times square root of x minus 2 square root of y over 3 square root of x times the quantity square root of x minus 2 square root of y. Square root of x times the square root of x gives us x. Square root of x times negative 2 square root of, that should be the square root of y, is negative 2 square root of xy. And 2 square root of y times square root of x is plus 2 square root of xy. And then 2 square root of y times negative 2 square root of y is going to be negative 4y. And on the bottom, you can go ahead and distribute this. It's not going to be able, we're not going to be able to cancel anything because we won't have any square roots left up in our numerator when we're done. And so 3 square root of x times square root of x is 3x. And then minus 3 square root of x times negative 2 square root of y is going to be negative 6 square root of xy. So these two middle terms again will be 0, and so we have x minus 4y on the top, and on the bottom we have 3x minus 6 squared of xy. And that's the end of our lecture on rationalizing numerators. If you have any questions, let me know. Thanks.